It's been very busy since the exam questions were released. I glanced at these, but I haven't had a chance to look over them deeply, but I'm going to go ahead and work out a solution to them, and we'll see when the grading route, scoring route comes out, how we did. So a large exercise center has several thousand members from age 18 to 55, several thousand members age 56 and older. Manager of the center considering offering online fitness classes, investigating whether members' opinions of taking online fitness classes differ by age. Manager selected a random sample of 170, and this is exercise center members ages 18 to 55. Random sample of 230 ages 56 and older. Manager found that 51 of the 170, so P1 is 51 out of 170. And 79 of 56 and older. So P2 is going to be 79 out of 230. Those are our sample proportions. P hat 1, right? P hat 2. The significance level alpha equals 0.05. The data provide convincing statistical evidence of a difference in the proportion of all exercise center members ages 18 to 55 be interested in taking online fitness classes in proportion of all exercise center members from age 56 and older be interested. Okay. When I see these words, I know we're doing a hypothesis test. We have two proportions, so we're going to do a two proportion z-test. Population proportion. We're going to set our conditions, check our conditions, and we did have random samples. Two different random samples. We have, since we're doing a two sample, we're checking for the data provide convincing of a difference, and that means our assumption is going to be that P1, let's go ahead and write the hypothesis here, H naught is going to be that P1 equals P2, and this one we're going to go ahead and label this, even though we should coincide here, we're going to go ahead and say that P1 equals a proportion of 18 to 55 who would take classes in P2 proportion of 56 and older who would take the classes. And our null hypothesis is going to be that P1 is not equal to P2. Since this is a two-sample z-test, two-proportion z-test, where we're assuming that the two proportions are equal, we have to use the combined proportion. So we're going to have the combined proportion Z for the sample distribution is P1, P hat 1 times N1 plus P hat 2 times N2 over N1 plus N2. That's the combined proportion. Let's get a calculator and figure out what that is. Calculator. check, make sure. So we have 51 plus 79. Divided by, let's go through the process. $170 plus 230. Yep. Yep, 400. Oops, 2. Didn't put parentheses there either. 0.325. And so 0.325 times 400. Be our N times P hat combined. That's greater than 10.
Braden Betts, come to the high school office, please. Braden Betts, come to the high school office.
Minus 0.325 times 400. It's going to equal 270, and that's greater than 10. Check that one. And we can assume, because it says a large fitness center, I think, large exercise center, we assume more than 4,000 members. So our conditions are checked. Now we're going to run the test on the calculator. So we're going to do a 2-prop Z test. We're going to have x1 was 51, 170, and x2 was 79, 230. We're doing the not equal to. We're going to calculate. We have our Z is negative 0.9177. Our P value is 0.3587. And our P hat means already. So we have calculations. So we've done name the test, check the conditions, made our hypotheses, performed our calculations, and now for our conclusion and context. Sorry, drawing a blank here, done this too many times. Because our p-value, 0.3587, is greater than 0.05, we fail to reject null hypothesis. And there is insufficient evidence to conclude there is a difference in the proportion of members who would take online classes in the 18 to 55 and 55 plus, 56 plus age groups. that's my solution to number one. What do you think?